Everyone got it right. I'm assuming everyone knew how to do it. Let's go through it pretty quickly. So we have a right triangle. And we can't just randomly assign letters to things because it does say T is 90 degrees. So T has to be here. Then we can go R, S, whatever order you did it in. Well, we're looking for this measure right here. Well, it does say that RT equals 11 and RS equals 28. So do I use sine, cosine, or tangent? Grace?
Cosine?
I use cosine because it's ka, right? Adjacent over hypotenuse. So we're using ka. What did you use?
You used tangent and I somehow got it right.
Huh.
Well,
You must have it must have been the closest. Yeah, we have to use cosine. Make sure you label stuff correctly, otherwise you lose a whole bunch of points. So it is,
68.
you didn't label your hypotenuse.
Yeah, because I labeled it wrong.
You
so
said
that's why I
ST was
used
that.
that.
Yeah, RS should be.
How did that work? Oh,
Yeah,
is
but
it
how did it
because
work?
tan sine of...
I assume he got lucky and it wasn't actually 67 degrees. He was just
68.
close. Yeah, it was
So I just
68. So he was actually.
Rounding.
So 68's way off compared to 67.
Okay.
All right, so you have to use cosine. And we would use cosine of x equals adjacent over hypotenuse. But the problem is that doesn't give me my x. So we have to switch this up to be x equals the cosine inverse of 11 over 28, which is about 67 degrees. Make sure you label your stuff correctly on the test. A problem like this shouldn't take you a full 5 minutes, like we kind of had in class. All right, we're going to go through the lesson, then we'll go through questions on the homework, because the homework was long and we had a bunch of stuff. I would like, if you did it and took the time to do it, awesome, then we can get started. All right, we have two things we're going to talk about. We're going to talk about the angle of elevation and the angle of depression. Well, the angle of elevation, it's the angle formed by the horizontal line and observer's line of sight to an object above the horizontal. So, this direction here, let's do it in red. This here is our angle of elevation because you are looking up. Up tells you its angle of elevation. Just changing the way we're looking, if I'm looking down, it becomes our angle of depression. So angle of depression is always going to be the angle that goes down. So an angle of depression is the angle formed by the horizontal line and an observer's line of sight to an object below the horizontal line. So if you look at this picture down below, I both have an angle of elevation and I have an angle of depression listed here. So this angle here, this 35 degrees on the bottom, is up. So it is our elevation. That's a good way to use this pencil. We'll just go like this. And the lighthouse looking down at the boat would be our angle of depression. Now here's the important part. Here is the important part. Note that this angle of depression is the same degree measure as this angle of elevation. And it always will work that way because we have two horizontal lines. We have this is parallel to that line. So our angle of depression and elevation is going to be the same because of alternate interior angles. So alternate interior angles tell me that this angle of depression from a lighthouse to the boat will be the same measure as the elevation of the boat to the lighthouse. And that's due to alternate interior angles. Remember, I don't write every single note you need. So I see Grace filling in that nice big blank I put there with information. That's awesome. I don't just leave blanks for the fun of it, but I'm not always going to fill them in because sometimes there's sentences and I don't want to write sentences on here. So once again, the lighthouse depression angle is the same as that boat's elevation angle. That can be really important. That can be really important because I could give you this lighthouse's depression. I could give you the height of the lighthouse, and you actually have to use the boat's elevation, knowing that these two things are the same. So make sure you understand that. If I give you the lighthouse depression, you also know the boat's elevation. All right, Marco trains pigeons on the roof of his building. Classify each angle as an angle of elevation or an angle of depression. If measure of angle 1 equals 45 degrees and measure of angle 2 equals 30 degrees, what are the other measures? So let's start with angle 1. Yes?
I have a question.
Yeah. Mhm.
Thing. So like, what if you said if you give us the angle of depression of lighthouse,
Yep.
and then you said we know that
So let's say,
elevation.
for future reference, I give you that,
Yeah.
and I tell you this lighthouse is what? That's a big lighthouse, 200 feet. Well, this is the right triangle I actually want to use. This triangle right here.
Okay.
So let's say I ask for the distance from the boat to the lighthouse. Well, you'd have to recognize that this is also 35 degrees, so you can actually use this triangle.
Okay, but you said that it doesn't. What if like it doesn't? If it's not parallel.
It always will be.
Oh, if it's not parallel, then it doesn't work.
Well, we make it parallel because the whole definition of depression and elevation is that we're using a horizontal line.
Oh.
So we're starting the definition with horizontal lines.
Okay.
We're starting the definition with that, so it has to be that way. So yes, those will always be parallel. Always. Always, always, always in these problems. It won't not if I don't give you a problem, if I just do a drawing that isn't angle of depression and elevation, don't turn it into an elevation and depression. Does that make sense?
Yeah.
As soon as I talk about depression, elevation, you know that this is true. This is automatically true. All right, so we have Marco training pigeons. We said angle 1. Let's talk about angle 1. Is angle 1 elevation or depression? Evan.
Elevation.
It is elevation. And I'm also going to put measure of angle 1 equals 45 degrees. And maybe I'm going to write 45 degrees here. All right, measure of angle 2. Is that elevation or depression? Akshay, is 2 elevation or depression?
Depression.
It is depression, yep. It's depressed. It's going, depression. And it also says that the measure of angle 2, they already gave me that one, equals 30 degrees. So let's go ahead and put 30 degrees here. All right, measure of angle 3. Is that elevation or depression? Sabrina.
That would be depression.
It would be depression because we're at the bird's height, right? And the bird has to look down at us, so that will be depression. And who can give me the measure of that angle? So we have measure of angle 3 equals, talk to you. Jacob.
30.
It is going to be third. No.
3. 45.
It is going to be 45 degrees. Make sure if you're working ahead, you stay with us because I still can ask you questions. So all of these lines are actually parallel. So alternate interior angles would tell me that this angle 3 is also 45 degrees. All right, our final one, angle 4, is that elevation or depression? Lydia.
Elevation.
It is elevation because the bird is now looking up at him. So that is elevation. And what's the measure of that one?
30 degrees.
Oh, thanks. 30 degrees. No, that's fine.
Are we gonna be able to just like look at it and say that's like?
Well, you could draw a picture and see
I
it.
mean, like,
And the word problems will tell you. They'll be like a bird's flying over and its angle of depression is. So depression would be the bird looking down.
oh, okay.
All right?
For that, okay.
Yep. And we have 2 examples. We have the angle of elevation from a boat to an edge of a cliff. So picture yourself as a boat. You're looking up at a cliff. So let's go ahead and draw that. Let's draw a nifty little boat. Oh, that's a pretty sweet boat. Got a motor on there. Got some propellers. Got some guys in there. All right, that's my boat. Here's our water. Here's our cliff. And the boat is looking up at the cliff because it's angle of elevation, and it's 38 degrees. Since it's elevation, it is the up. If point A is, so we're talking about boat, if point A is 80 feet from the base, so that would be 80 feet down here. So point A is just the front of the boat. We'll call that A. It's 80 feet from the base of the cliff. How high is the cliff? So we're looking for this height. Let's call it X. Well, we have a right triangle because the cliff we're saying is straight up. We have a right triangle, so that means we're going to use either sine, cosine, or tangent. What would I use to actually solve for that X? Robin? I would use tangent. We would say, well, since it's opposite over adjacent, we'll use tangent. And tangent of that 38 degrees is going to equal opposite, which is X, over adjacent, which is 80 feet. Well, we multiply both sides by 80 to cancel out that 80, 80 on this side, and we're going to have X equals 80 times the tangent of 38 degrees. Evan, do you have a question or the answer?
Oh, I have the answer.
Okay, what do you think the answer is?
It's 62.5, so 63.
63 degrees. Did we get 63 degrees? No, we shouldn't get degrees at all.
Oh, sorry,
Yeah.
Wait, I got. Oh, I messed up. I'm sorry.
Let me
just
see what
put
I got.
sine instead of tangent.
Since it is an elevation with feet, I generally round it to the nearest tenth if it doesn't tell me. So I just did 62.5. But you were perfectly fine, minus the degree part.
Yeah.
And on the test, it will specifically say what to round to. And so if I don't tell you what to round to, generally you do like to the 10th is usually a pretty good approximation. Yep, but you would have been 100% fine because I would look at if I had this on a test, I would look at the question and say, did I tell you to round to something? And if I have to say no, then I have to give you those points. So you were good. And realistically, I care more about this than this, right? If you round something funky, you lose maybe half a point, maybe. If you do it once, maybe I don't even take any points off. If you consistently do it, then you start losing half points. All right, our next one is a good example to go through because we have to do something at the end because they specify something. So it says you measure the angle of elevation from your eye level, which is 5 feet off the ground, to the top of a light post to be 35 degrees. So we're looking up at the lighthouse, or at the light post. So let's do an awesome drawing of it. So we have, that's you. Looks like you. Looks like every one of you. And then we have a light post. There we go. That's a light post. And we are looking up at the light post. But we're looking at eye level. So it's our eyes looking at the top of that. So this is actually the right triangle I'm creating. It's not from my feet. It's from my eyes. Or from your eyes, I should say. And your eyes are 5 feet off the ground. So the distance from here... Did my pencil just quit working? Yeah, it's on the struggle bus right now. All right, from here to here is 5 feet. That's important because it does say what is the height of the light post. So we have to add that 5 feet in here. All right, so from here to here is 5 feet. So let's continue on. So it says that looking up is 35 degrees. And we know we are 20 feet away. And we're looking for the height of the post. So I'm looking for that X right there. Well, this once again will be a tangent problem because it is opposite over adjacent. So we would say the tangent of that 35 degrees equals opposite over adjacent. So X is going to equal 20 times tangent of 35 degrees. And I'm going to say to the nearest foot, what does that equal? To the nearest foot, what does it equal, actually?
14 feet.
14 feet. So is my answer 14 feet and I'm done and I circle it and I say I get all the points? You look very angry at that. What do I need to do?
No, I have to add 5.
I have to add 5.
From eye level and
Yep.
5 feet.
Yep, so the light post is going to equal 14 plus that additional 5, which equals 19 feet. Bless you. Be careful on these problems because some are like you holding a kite and your hand is 6 feet off the ground. Or you're looking at something and you're 3 meters off the ground. So make sure you calculate that. Do a good drawing. A lot of these do have drawings just to get you started, and then it stops having drawings. The answer should be on the very last page on the bottom. All right, very last page on the bottom. Correct me if I'm wrong.
What if we don't have the answers? We can't correct it.
The answers are on the bottom.
No, correct me if I'm wrong.
I see. All right, double check if you think one is right and my answers are wrong. I didn't recheck these yet. I haven't rechecked these. I was kind of scrambling to get that review to you today, so you had time to work on it tonight. So it wasn't all tomorrow in class and then tomorrow night, and then also you have a bunch of questions on Thursday, which is the test day. So you'll notice, hopefully all those answers are still correct. I checked like half of them. I did a scatter shot to make sure last year looked correct. The answer guide, your review, you'll notice the numbers are kind of out of order because I took it straight out of the book and I didn't change the numbers, so that's why it's a little bit out of order. But it's a good review. Hopefully you don't need to use it too much. Do it, and hopefully you know it because we only had a week's worth of material, so you should remember most of it. None of it should be like, oh, what's tangent? Because we continually used all of it all along. All right. This is probably the hardest section just because it's application. It's drawing pictures. You have to actually apply it. Make sure if you're struggling with tangent, sine, cosine, you really practice this in the next 2 days. All right, any questions for me? Okay, then I will go over questions from the homework. Questions from the homework. So that would be 8.6, sine and cosine. Yes?
Number 21.
All right, 21 says the diagonals of a rectangle A, B, C, D are 18 centimeters long and intersect at 34 degrees. So what I'm picturing here is we have a rectangle. I'm going to draw stuff and then I'm going to erase it. And each of these diagonals is 18 centimeters long. So how long is it from the mid to here?
9.
It's going to be 9. Yeah. Because with a rectangle, they bisect each other. So this is 9, this is 9, this is 9, this is 9. All right, let's continue reading. So then it says they intersect in a 34 degree angle. So this right here is 34. You could pick any angle, but I'm going to pick the one that looks like it's 34. So that angle is 34 degrees. Here's the problem. We need to have a right angle to solve for anything. And in fact, what are we even solving for? It says find the length and width of the rectangle. So what you need to do is you need to cut this triangle in half to create a 90 degree or a right triangle. So now when I bring out this triangle, we have the hypotenuse is 9. This angle is not 34 degrees. It is half of 34, which is 17 degrees. All right, now we need to find x and we need to find y. And why we're finding both of these, if I find x, we multiply it by 2 and I have the width, right? Because if this is x, this is also x, so x plus x gives me my width. My y is also half my length. Because if we picture this length here, this is that y, so that would be my other y. So you just need to find y, multiply it by 2, and that's your length. Find x, multiply it by 2, and that's your width. Does that all make sense? Good. Make sure you know how to do those problems. Actually,
the answer key for the length, you put that it was 17, but I thought it was 34.
Did I not multiply it by 2?
Yeah, I don't think you.
Hang on. No, it's 8.6 times 2.
Yeah, it's 17. You wrote 2 times 17.
Oh, I did write. I wrote 2 times 17, which isn't what I was supposed to. Yeah, I was supposed to write 2 times 8.6. So I just wrote what I multiplied wrong. Actually, you should have came out with 8.6.
Oh, I didn't come up with 8.6.
Because you should have had. Let's do it real quick. What way did you do it?
So I knew that was 35 degrees and that there's 2 other angles.
Well, it's 34 degrees.
34.
Okay.
Were equal, so then you find out that they were each 73, and then I did the big right triangle.
Oh, yeah, that works too. Yep. Yep, that works too. Whatever right triangle you use is fine. Okay. If I was looking for y, I would use. So we would use that's adjacent over hypotenuse. So I'd use cosine of 17 degrees equals adjacent over that. We would do y equals 9 times cosine of 17 degrees, which should be about that 8.6 if you plug in your calculator.
Oh, now I know what I did. I used sine instead of cosine.
Okay, yeah, make sure you use the right one. Because sine would get you 17. All right, other questions from the homework? Grace.
Can you explain number 19? Number 19?
Sure. So number 19, let's put the whole thing up there. So it says, in triangle ABC, measure of angle B equals measure of angle C equals 72 degrees. So I said this is 72, this is 72, which I immediately, as soon as I drew this picture, said that it must be an isosceles triangle because they have base angles that are the same. Then it says that BC equals 10. So if BC equals 10, and I divide this in half, we have a right triangle with the bases of 5 and 5.
I split it. I didn't think.
Oh, okay. Yeah, if you don't have a right triangle,
Yeah, I was like.
ask yourself, how can I split it to make a right triangle? So anytime we have an isosceles triangle, just split it in half for what we're doing right now. That should be kind of your thought process.
Okay.
Yeah,
Could I ask another question?
sure.
For number 16, I got 340 meters, and it was 350 meters.
Well, it says around your answer to the nearest 50 meters.
Oh, I was like, okay.
So you have to ask yourself what's closer, 350 or 300.
Oh, okay. I was confused.
Nope. You had the right answer. Amber.
17.
So we have a ladder which reaches the higher up on the wall when placed at 70 degrees, then when placed at 60 degrees. How much higher to the nearest tenth of a meter is it? So it's a 6-foot ladder. It's a 6-foot ladder, and let's just kind of draw our picture. So we have one placement. So my snap grid is not helping me out right now. But anyway, that's my 6-foot ladder. So that's 6 feet. And we have one placed at 60 degrees. And then we have that same picture, but now it has a slightly bigger angle against that wall. My ladder is still 6 feet. But now it said it was 60 and 70 degrees. So in fact, I have it flipped. But one is 70 degrees, one is 60 degrees. So all you have to do is, we're trying to find how high up you can go. How much higher? So you need to solve for this x, and then this, maybe we'll call it y instead of x. And you just take the bigger one, subtract the smaller one away.
Oh, okay, that's a little bit.
Does that make sense? Yeah, it was just setting up two triangles, one with 60 degrees, one with 70 degrees with a 6-foot hypotenuse. All right, other questions from the homework? Yeah, Stephen. In triangle, AB equals AC equals 13 and BC equals 10. This is the exact problem as 19. This is exactly the same setup as 19. What you need to do every single time I give you an isosceles triangle and its trig is draw your isosceles triangle